Hello everyone, I am Assistant Professor Urmi Shah from ICT Department of LG Institute of Engineering and Technology. Today we will be starting or continuing with the chapter Amplitude Modulation, that is Unit 3 of your syllabus, and we will be moving ahead with a few more topics in this section. So in the previous session, all of us have studied or discussed regarding the amplitude modulation technique, what are its scheme, what is its theoretical analysis, how amplitude modulation equation is written, all we have discussed in the previous session. In today's session, we are going to look upon the variations in amplitude modulation scheme and few more analysis we will be doing in this module. So let's start with this module, that is amplitude modulation scheme. So all of you might be knowing that basically in amplitude modulation we are varying the amplitude of signal and transmitting it from one end to another end such that signal can be reproduced or retrieved back originally which was transmitted from one end to another end. Now, following are the topics that we are going to cover in this session, and these topics are double sideband, full carrier modulation. Then we are going to cover double sideband, suppressed carrier modulation, and then we are going to see is single sideband modulation. Following these three topics, we will be seeing in our today's session. So let's start with the first topic, that is double sideband full carrier modulation. Now what are these words meaning? Double sideband, full carrier, suppressed carrier, single sideband. All these terminologies are related to the bandwidth of the modulated signal. Bandwidth of the modulated signal itself means that the range of frequencies which are going to carry our signal from one end to another end. So these terminologies are related to the bandwidth or the frequency spectrum of modulated signal. So now let's start with the first modulation type, that is double sideband full carrier modulation. In this, your modulated signal will be having two sidebands as well as carrier will be also present in the frequency spectrum of double sideband full carrier modulation signal. So here this is ideal amplitude modulation scheme which we have discussed, that is normal amplitude modulation where we are multiplying the message signal with the carrier signal and then the modulated signal is passed from one end to another end. So basically these are the blocks that modulated signal, message signal is multiplied with the carrier signal, and so basically here the modulated signal is formed by multiplying the message signal, that is m of t, with the carrier signal, and then it is transmitted as a modulated signal from transmitter end to receiver end. So this is about DSB-FC modulation scheme. Now next we will be looking upon is the equation or waveform representation of DSB-SC. As we have seen in the previous slide that we are multiplying m of t with cos 2 pi fct. M of t is our message signal, fc is our carrier frequency, and we will be multiplying the amplitude of signal with the carrier frequency term. So the overall equation of DSB-FC modulated signal is m of t multiplied by cos 2 pi fct plus a cos 2 pi fct. So this is the equation for amplitude modulated signal. Now next you can here imagine clearly by seeing this waveform that m of t is our message signal. Now if you want to transmit this message signal from one end to another end, carrier signal is going to carry the message signal. So you will multiply this message signal with a carrier signal, and the carrier signal formulation is EC multiplied by sine 2 pi FCT, and message signal formulation is EM multiplied by sine 2 pi FMT, where EC and EM are the amplitude of message signal and carrier signal. EC is the amplitude of your carrier signal and EM is the amplitude of your message signal, and FM and FC are the frequency of message signal and carrier signal. So these are the formulations of message signal and carrier signal. Next we will be looking upon is the modulated signal, that is the DSP-FC signal after performing modulation. So the formula for this is EC plus M of T, that is amplitude of carrier signal plus the message signal multiplied by sine 2 pi FCT, that is your carrier signal frequency. So this is the overall modulated signal amplitude, and this will be the look of DSP FC signal. As you can see, the envelope structure is created as carrier frequency whenever multiplied with your message signal terms, it is going to provide a envelope structure from where your message signal or modulated signal is going to transmit from transmitter end to receiver end. So this is the waveform analysis of DSP-FC modulated signal. Next we will be looking upon is the modulation index. Now basically we have seen in the last session that modulation index is the ratio of amplitude of message signal divided by the amplitude of carrier signal. So it is basically MP upon A over here. MP is your message signal amplitude and A is your carrier signal amplitude. So basically it is a formulation like this: E max minus E minimum upon E max plus E minimum, as the message signal amplitude is varying from maximum E, that is your maximum modulated signal amplitude, to minimum modulated signal amplitude, and your carrier signal amplitude is overall maximum plus minimum amplitude. So this is the formulation of modulation index, that is E max minus E minimum upon E max plus E minimum. So this is the analysis or modulation index of DSP-FC signal. Now if your modulation index is equal to 1, then it is ideal modulation condition. If it is less than 1, then the signal is under modulated condition. And if the signal is having modulation index greater than 1, if M is greater than 1, then your signal is over modulated. It is more modulated than the required modulation. So ideally your modulation index should be 1 if you want to transmit it ideally from one end to another end without loss of information or further addition of noise. So this is all about ideal modulation, under modulation and over modulation, which can be identified by looking upon the modulation index of your signal. So this is about the modulation index of amplitude modulated signal. Now next we will be looking upon is the sideband and carrier power. As we all know, in DSP-FC signal there will be two sidebands, that is upper sideband and lower sideband, and there will be one carrier term, that is your carrier frequency term. So here now the power which is contributed due to presence of carrier, that will be carrier power. So the modulation index based carrier power formulation is PC is equal to A square by 2, or we can say the amplitude of carrier signal square by 2, also carrier power is associated with the power caused due to the carrier signal. So it is A square by 2 where A is the amplitude of carrier signal. Then the next is the sideband power. This sideband power is having the formulation as Pm by 2, that is the power contributed by message signal by 2. So this is the sideband power. So the total power is the summation of carrier power plus message signal power, that is Pc plus Ps, power caused due to carrier as well as sideband. So the power efficiency for this DSB-FC signal is eta, represented by the term eta, that is equal to Ps upon Pc plus Ps, where Ps is your sideband power and Pc is your carrier power. So the formulation is like this: mu square upon 2 plus mu square, where mu is your modulation index, and you can also have Ps upon Pc plus Ps if the values of carrier power and sideband power are given to you. So the P total, that is the total power of your DSB-FC signal, is Pc multiplied by 1 plus mu square upon 2. So this is the formulation of DSB-FC in terms of power, efficiency and modulation index. So this is all about DSB-FC signal. The advantages of DSB-FC signal are: it is very simple to demodulate, as you can demodulate the DSB-FC signal using envelope detector circuit, which we will be seeing in the upcoming session. Plus this is a linear modulation technique which is applied easily anywhere. Then the disadvantage of DSB-FC signal is it is having low power efficiency and the transmission bandwidth is quite higher in terms of the message signal bandwidth. So power and bandwidth, these are the factors which are causing drawback for DSB-FC signal. So this is all about DSB-FC signal and its pros and cons which we have discussed here. So now the next kind of signal is, or next kind of modulation scheme is DSB-SC signal, that is double sideband suppressed carrier. So here in the frequency spectrum of DSB-SC signal, you will have two sideband, that is upper sideband and lower sideband, but the middle carrier signal in the frequency spectrum of DSB-SC scheme, modulation scheme, it will be suppressed. It won't be counted over here. So to reduce the bandwidth and power efficiency of DSB-SC modulation scheme is proposed. Here the carrier signal is suppressed in terms of frequency spectrum. So here whenever we will multiply our modulated signal with the carrier signal, the final modulated output will be in form of multiplication of message signal with carrier signal. So here this is the DSB-SC spectrum. As you can see in the top, that is your message signal which you are going to modulate using the carrier signal. Whenever we will multiply our message signal and carrier signal, in the output either you will be having the upper sideband or you will be having the lower sideband, but the carrier frequency will be suppressed. So this is DSB-SC signal. Only presence of the sidebands are there, that is upper sideband and lower sideband. Otherwise your carrier frequency is suppressed. Now the another kind of modulation scheme is single sideband modulation. In single sideband, only LSB or USB, that is only one sideband will be present. Otherwise the other sideband as well as the carrier signal will be suppressed. So this is one of the finest or the most efficient technique whenever we are comparing DSB-FC, DSB-SC and single sideband, as it is having very limited amount of bandwidth and it will be more power efficient compared to the rest of two. So the single sideband is a kind of amplitude modulation technique where both carrier and one sideband are attenuated or they are suppressed. Only there will be one single sideband present. Either it can be upper sideband or it can be lower sideband. So over here, if there is a presence of upper sideband in your modulated output, that means your lower sideband is suppressed. And if there is a presence of lower sideband, then that means the upper sideband is suppressed. So this is all about single sideband modulation scheme. The name itself suggests that there will be presence of only one sideband in the frequency spectrum of SSB modulation scheme. So now the next we will be seeing is the spectrum of single sideband modulation scheme. As you can see over here, there is only one sideband present, that is the upper sideband, which is summation of carrier frequency and message frequency. So you can see here only one sideband is needed, so only that much bandwidth is needed to pass the signal from one end to another end. So your bandwidth is also reduced and the power required to transmit that much signal is also reduced. So this is about single sideband, which we have studied it here. So now in the upcoming sessions, we will be learning or we will be seeing is the generation of amplitude modulated signal, that is using amplitude modulations. Then we will be seeing is amplitude demodulator circuits, and then we will be seeing the amplitude modulated transmitter. So these are the topics which we will be studying in the upcoming session. In today's session, we have studied the variations of amplitude modulated scheme. In this, we have studied DSB-FC, DSB-SC and single sideband. So these are the three variations which we have seen in this session. Now what are its pros and what are its cons, what are the advantages and what are the limitations of all the three modulation schemes that we have seen, and you have to study this in detail, as these three topics are one of the most important topics and these are frequently asked in your final exam. So you all need to refer this session again and again, and if you face any difficulty, you can refer the following reference book for this topic, that is Dennis Roddy and John Cullen, which is one of the finest books for analog communication. So you can refer any of these books, and in the upcoming session we will be learning how to demodulate the amplitude modulated signal, because once you have sent the modulated signal from one end to another end, at the receiver end we need to again retrieve it back into original form. So those techniques we will be seeing in the upcoming next session, that is all about amplitude demodulation. Once you have performed modulation, your signal is modulated, you are transmitting it from transmitter end to receiver end. Now at the receiver end, if we want to retrieve the original message signal, if we want to reproduce the original message signal, then we need to require the demodulator circuit. So we will be seeing the various demodulator circuit in the next session. Thank you very much for watching this session. Thank you.